Welcome everyone, thanks for joining us tonight. We're going to be talking about soil testing and how to interpret your soil test results. I want to take a moment and introduce myself. My name is Nicole Warren. I'm a farm program specialist here at Pierce Conservation District, and I provide assistance to landowners and farmers in the Puyallup and White River watersheds. I'm part of a farm team that provides service throughout Pierce County, and I work with community members and help them address their goals and concerns on their farm by implementing best practices that protect soil and water quality and habitat, while at the same time improving the health of their land, the health of their animals, and the viability of their farm. I have a strong background in soil agronomy and soil health, and I'm excited you're joining us tonight, and I look forward to sharing more information and answering your questions. This workshop's being hosted by Pierce Conservation District. We've been serving our community since 1949, and we assist community members and farmers in Pierce County. If you're joining us from outside of Pierce County, we encourage you to connect with your local conservation district, and you can reach out if you don't know what the nearest conservation district is to you, and we can help connect you. We are one of 45 conservation districts in Washington state, and there are over 3,000 conservation districts nationally. We have many programs here at Pierce Conservation District and a dedicated team of staff and board members working to deliver those programs to you. We work with landowners, state, federal, and tribal government, and a variety of different city, local, state, and federal agencies in partnership to restore, enhance, and improve natural habitat and natural resources. Conservation districts are non-regulatory state agencies, and we were formed starting in the 1930s after the Dust Bowl as a local, place, and community-based response to protecting and managing natural resources. So all of our programs being, we're non-regulatory, is that they're voluntary. And anyone can reach out to us for assistance if they'd like to. And nationally, conservation districts provide educational, technical, and financial assistance to agricultural producers and community members and private landowners. And because conservation districts are locally oriented, we're able to build our programming and offerings around the specific needs of our local community. This workshop's a part of that local response to local needs. Our programs support community-driven solutions to local environmental challenges to protect and restore soil, water, habitat, and other natural resources. Pierce Conservation Districts has a variety of programs. We have our Farm Assistance and Planning program, which I'm a part of, and the goal there really being to build a robust local agricultural community and reduce potential negative impacts on soil, water, air, plants, animals, and human resources. We do provide a lot of technical education and assistance to improve stewardship practices and help farms be economically sustainable. We have our Harvest Pierce County program that focuses on education, connection, and equity through cultivating community-based food systems. It's more of like an urban focus a bit, and they increase food security through a gleaning project, community gardens, and a program called Share the Harvest. We also have a Farm Foundations program on a farm that we run called Goss Farm, and there are always a variety of educational workshop series that they provide on edible garden series and fruit tree education. Our environmental education program works with K through 12 students on the importance of environmental stewardship and how they can take action. They do things like classroom presentations, organizing different field trips, events, and workshops, that kind of thing. Our climate resiliency program works to help build a broad, diverse, and inclusive approach to, if there's, approach to things like renewable energy and opportunities like that on farmland, and assisting Washington farmers and rural community members to make that transition to renewable energy and upgrade existing equipment and infrastructure at a low cost that's energy efficient. Our habitat improvement program does a lot with different types of water body and nearshore habitat, and doing things like replanting native trees and shrubs to restore those ecosystem areas. Removing invasive weeds is a big part of that too, and there are a lot of volunteer opportunities with that program. And then last, our water quality program, which works to create an informing the public around like water quality and helping engage community in green stormwater programming, monitoring local waters, and actions like depaving, installing rain gardens, and planting trees in urban spaces and along streams. So lots of different things that are going on in our district, and pretty awesome team of folks making it happen. Okay, so I just want to dive right in and go over what we're going to cover tonight. We're going to start by just talking about the importance of soil structure and talk a bit about what soil testing tells us. We're going to talk about what nutrients crops need. We're going to dig into how to interpret a soil test, prioritizing what nutrients to apply once we figure out what's high, what's low, what we need to maybe add and focus on. We are going to do a little bit with calculating, like looking at your soil test and calculating how much fertilizer you need to use. We will just talk briefly about taking a sample and go over some other services and equipment that will be available to you. I always like to put things into perspective when talking about soil, and maybe make you as excited as I am about it. And there are some just really cool quotes. So I really like this one, which is just, to be a successful farmer, one must know the soil. And a Greek philosopher in 400 BC said this. And I kind of just love it because it's still completely true, and was said such a long time ago, and is still such a big piece of everything we do with food production. And this kind of follows it, which is just that despite all of our accomplishments, we owe our existence to a 6-inch layer of topsoil and the fact that it rains. And I kind of love that. Paul Harvey was one of America's first famous radio hosts and gave this speech in 1978 at the Future Farmers of America convention. And he had this speech, and this famous quote just still lives on today. And just being that we rely on that topsoil and that rainwater for almost all the agriculture in our country, it's easy to forget how essential and simple that actually is when it's not something we interact with in our everyday life. We don't always have to worry about whether or not the next rain is going to come in time to keep our carrot seeds that just germinate in our soil alive, or pay attention to when the rains lets up in the spring, when farmers are waiting to put crops in the ground or get their livestock out on pasture. But without tillable soil and without enough rainfall and glacial melt to fill our streams and rivers, we wouldn't be able to have the agricultural system that we do. This is another fun brief framing that I like to do. So an acre furrow refers to the first 6 inches of soil in an acre. And in those 6 inches, the soil weighs 2 million pounds. It takes 3,000 years to develop those 6 inches. When you're just talking about literally parent rock material breaking down into soil. It contains 5,000 pounds of soil microbial life. So all of those different organisms in there. It can store water and nutrients and carbon. And it's capable of holding up to 9,000 tons of water, depending on the soil type and climate conditions. It's just kind of cool to think about in perspective how important that is and what it can do. So we're just going to talk briefly about taking a soil sample. I thought that would be a good place to start. So these pictures just kind of show you as you're going along, you kind of take random samples or go in a zigzag pattern around the field. And this picture shows you how you would do it with a shovel. You can also do it with like a soil probe, but most of you don't have access to that, and a shovel's just fine. So you're kind of taking a slice out. That's kind of and taking it at a bunch of different spots along the field to then mix it together and kind of have an aggregate, have kind of an average of what's going on in that field. And if you had different site conditions, like there's an area that gets really more, wetter than other places, or there's ponding, or there's an area that you can tell is a different soil type, or you've done different management on it, we usually divide up our samples based on that. But if you have a field that's kind of had the same management, kind of has the same soil and drainage, usually we just do one sample in that area, and that's good. If you have a pasture, we go down 6 inches. So we just want the first 6 inches of soil. We kind of remove the first inch or so of grass and roots. We don't want that. We want what's below that and kind of in that main rooting zone. If you have vegetable crops, you go down to about 8 inches, which is kind of like that tillable zone. So that's kind of a point of reference there. And pastures and vegetable production are what we're going to talk about tonight. So what does testing the soil tell us? We learn about the physical properties of the soil. So, concentration of sand, silt, and clay, and what those certain things do. We learn about nutrient levels. So, how much nitrogen is there? What's the calcium level? Those types of things. It estimates nutrient availability. So we're going to talk about that tonight in detail. But it's about the amount of, that's available to the plant. We're gonna get there in a little bit. It can show us nutrient deficiencies. So what nutrients we need more of that we're lacking at the moment. It can measure the pH over time. It helps us figure out, applying the right amount of what nutrients we need and not more than that. And by applying the right amount, we do reduce risks of pollution. So, if the crops are going to uptake what they can, and what's left over is either going to leach down through the soil profile into the groundwater or run off into nearby surface waters. So we're going to start by talking about soil structure and what we mean when we refer to that. So soil structure refers to how soil particles group together into what's called aggregates. And an aggregate is kind of like how the soil particles, they kind of stack on top of each other and they create little spaces that hold air and water. So that's a pretty big portion of what they're made up of. And that's where soil, our where plant roots are getting their air and water from most of the time. And then it also has the mineral base, which is kind of the minerals that are attached to the sand, silt, and clay that come with it, and organic matter, which is a pretty small percentage of it as well. So soil structure is relatively unchangeable, or it takes decades to change due to the physical properties of the soil. So when we talk about soil structure, we can change it based on management practices. However, it does take time, and a lot of the types of practices that we do, like tillage, break up these aggregates and change, just have an impact on the soil and what it does, what it's capable of doing. So what does soil structure look like? This is a picture of kind of just a chunk of soil. And what I do like about this picture is it shows you some different roots. You can kind of see roots going through. So that's the root zone, the rhizosphere. Earthworms and roots, they push soil, they create pathways and like holes and different things that roots and water and air can hold into, or roots can also move into. And there's always like some kind of litter layer at the top of organic things breaking down. And pore spaces is what we talk about when we talk about the soil particles stacked on top of each other and the spaces that are kind of in between them. I want to show you a quick look at some specific pieces of soil structure that are more difficult to know are happening, but are really interesting. So we already talked about how clay, silt, and sand stack together, and that these soil particles form an aggregate. The other thing that holds soil aggregates together is actually soil organisms. So these photos show examples of how soil structure can be physically stabilized. Plant roots play a big role in holding soil particles together and reducing the impact of compaction. We need to have really healthy plant roots to have a really healthy root system. And the bottom photo shows microorganisms. Actually, they kind of, it's almost like a needle and thread, how they create these filaments, and they kind of intertwine between soil particles and aggregates, which is just really cool. So that's sort of some of the things that and the other thing is that earthworms create castings that what that does, and I think we're going to talk about it in the next slide a little bit more, because it's a little bit more of chemically what's happening. But the sort of slime that they leave behind is like a sugary substance that actually does the same thing here as bacteria, and creating these sugary protein substances, kind of how soil organisms chemically stabilize. So yeah, it just this has to do a bit more with like bacteria and fungi and how they produce these substances. It's almost thinking like a sticky glue is like one way to think about it. And yeah, earthworms kind of do a similar thing, and that's just another way that these soil particles are sticking together and have really positive benefits on soil health and soil structure that we're going to talk about. And there are a few different ways that we impact this and improve it that we'll kind of talk about a bit. So crop residues, having plants actually breaking down on the surface, whether that's mature grasses break, or some of the grasses in your pastures or hay fields breaking down, or in your vegetable cropping systems where you have cover cropping. Tillage practices have a pretty big impact on soil structure, so we do quite a bit of helping farmers come up with different ways of reducing that can have positive benefits on crop and land management and soil health and those types of things. Maintaining and increasing organic matter is a pretty big thing, and we're going to talk about that next. And then minimizing disturbance when soils are saturated, so not going out to the fields or putting equipment on the fields when it's very wet. That can, cause some different compaction and really change the soil structure. So I really like to show this diagram, which just talks about like soil improvement as a staircase. And so there are some pretty big things that happen initially that we can't see. So we start with an increase in biological activity, and that's when we start to see organic matter increase after that, which is one of the things that we notice quite a bit. And that soil tests help us see as well. Then you start to see improved nutrient cycling. So you start to see nutrients being more available to plants and more things breaking down constantly to create more nutrients available to plants. And after that is when we start to see improved soil structure, and we can really start to notice these changes. And one of the last things that happens as you improve the soil structure and soil fertility is that you actually improve water availability and the soil's ability to hold water. And that has to do with how organic matter, which we're going to talk about next, actually holds on to like chemically charged water molecules. So, and that can increase how much is able to be stored for plants to use at a later time. So we're going to dig into talking about and interpreting your soil test report. And I've got a soil test report up on the screen. And yeah, switching gears to the fun part. So being that this is an example of a soil test report you get back from the lab, it is a lot of information. And if you haven't ever seen one before, it's not super easy it's not in a super easy to digest format. So what we're going to do is we're going to kind of take it apart piece by piece and look at and talk about what each component means and the nutrient itself and the ranges that we need and that kind of thing. And my goal is to provide you with an in-depth yet brief overview of what is included in your soil test and how you can use it to determine what you need to apply in your pasture or your vegetable field. So first we're going to talk about soil pH. And soil pH is a measure of the alkalinity or acidity of the soil. It is determined by the amount of hydrogen ions that are in your soil. And really maybe one of the main takeaways with that is that as the amount of hydrogen ions in the soil increases, the pH decreases, thus becoming more acidic. So it's just important as we sort of frame soil pH in the next few slides. So what determines your soil pH? There are what's called soil forming factors. So looking at your soil structure, determining your soil pH, there's the texture, sand, silt, and clay provide different properties provide different charges that can have an impact on that as well. Just kind of what the base pH is, the starting pH, which we'll kind of talk about. The soil, so the mineral content of the soil plays a factor in that. And management practices can have a positive or a negative impact on pH. Kind of a big thing, especially in our region, is that annual rainfall actually acidifies the soil. So we're kind of always fighting that. And then irrigation water acidifies the soil too. One last thing that's kind of challenging is that fertilizer acidifies the soil. So as you can see, there's kind of all these things like working against you. And one of the reasons why improving soil pH and maintaining soil pH is such a big thing that people do. So pH. On this soil test report, the pH is 6. And the buffer index is 5.8. And the way that I kind of explain buffer index is it's what the soil always wants to revert back to. And that helps us determine the actual rate that we want to apply, and will let us cue us in on like how often we might need to apply limestone, which we'll talk about, to help change the pH, in this case to make it more alkaline, which is usually what we're doing in our climate. And why is soil pH important? So it affects how nutrients are available in the soil for plant growth, which is like how easily it is for them to uptake it and access it. It determines what's called the solubility of a nutrient. So how much nutrients are in solution in the soil. And I guess that's kind of the easiest way to describe it, which is like how easily a nutrient is absorbed through plant roots and plant leaves. So we're going to talk about nutrient availability and pH. And this is a look at our macronutrients: nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium. And our soils around here tend to be mildly or strongly acidic, and that's one piece. But this scale goes from 4 to 10. So 4 being really, really acidic and 10 being very alkaline. And this is the range that we're always kind of shooting for with crop production, with the majority of crop production, but definitely with pasture, hay, and vegetable crop production that we're going to talk about today. And this range is between 6 and 7. So, and that's the range that most vegetable crops prefer, and grass crops are a little bit more tolerant of acidity. So 5.5 to 6.5 is just fine as well. But as you can see, the way that this chart shows you is that basically as the nutrient itself on this diagram, let's look at potassium, for example. As you go to the left, as you go more acidic, it's showing you that the nutrient is less and less available. And on the flip side of that, if you're more alkaline, you can sort of see that things are different here too. So phosphorus is often a limiting nutrient to plant production. And as you can see in both of these examples, that either too acidic or too alkaline, phosphorus isn't as bioavailable. So that sweet spot can be really important for that nutrient in particular. And then these are our micronutrients. We've got iron, manganese, boron, copper, and zinc, and molybdenum. And you can see here too, the biggest thing with these guys is that at a higher alkalinity, that's when they're become a lot less available. So it's kind of the flip side than some of those macros that we were talking about. And as you can see, when it's more acidic, these are in okay ranges. In both cases, if you go lower or higher, you do have to start to worry about toxicity with these. So micronutrients, meaning that the plant only needs a little bit of them. So putting that all together and finding the right balance, looking at that 6 to 7 pH range has everything pretty available. So that's part of why we're really focusing on the pH there and always trying to keep it in that range. So how do you improve soil pH? The biggest thing that I work a lot with folks on to get a very fast result is applying limestone, which is crushed up lime rock, and it does a really good job with chemically reacting to the soil and making it more alkaline. Another piece of what improves soil pH is applying only the rate of fertilizer that you need, because as I said, fertilizer makes the soil more acidic. So if we apply more than we need, we're kind of working against ourselves. So manure and compost applications actually improve the pH, especially over time. The pH of composted manure and compost in general is a lot more close to that 6 to 7 range. And because it has a stable source of organic matter, that actually helps to buffer the pH and keep the pH in the range that we want it to be in. And crop residues and cover cropping also improve soil pH. While we just talked about how it improves soil structure, it's creating food that is broken down and turns into compost and turns into organic matter, having that good effect. So applying limestone to improve the pH. It does typically require multiple applications and a couple years to get to the desired pH range, especially if you're working in a perennial cropping system where you're not tilling, because tilling actually helps incorporate the limestone and have more contact with the soil, so the chemical reaction happens faster. So in vegetable systems, we often see that the pH can change faster just because of that management difference. We often do apply in fall for most crops, but if you have irrigated crops or you do have vegetable production in like tillage systems, spring applications can work just great as well. But the rainwater or irrigation water is really important in helping that chemical reaction to happen, which is why the fall, then all the rain that we get can help, bring that further into the soil profile and make the pH change happen faster. And that we usually test the pH levels of our soil every 3 to 5 years once we get it into the optimal range. So it might take 1, 2, or 3 years to get it into the optimal range. And after that, once we kind of have sort of a system in place and it's in the right range, then it's not as frequently do we have to check it and apply it and apply lime. So we're going to talk about soil organic matter a little bit. And soil organic matter consists of these different things here. So it's we've got fresh residue, actively decomposing plant residue, but it's mostly things that have decomposed and things that are stable. So we're going to kind of just talk about that list. So it's got decaying plant and animal tissues at various stages of decomposition. And I like to think of it as like dead, or it's alive, dying, dead, very dead, in terms of those being at different stages to get to the very stable form. It's also got alive and decaying cells and tissues of soil microorganisms. That's a big piece of it too. And the physical and chemical substances that soil organisms, microorganisms produce, which is what we talked about at the beginning. And why is soil organic matter important? It improves the soil's capacity to supply soil nutrients that can be uptaken by plants. It improves the soil's capacity to retain and store soil nutrients. So not only supply, but store for later use. Same with water, retain and store water. And so here's the soil test report where we have the organic matter listed. So for this soil sample for this vegetable producer, the organic matter content is 6%, which is pretty average for a lot of the soil types around here. And in a lot of other regions would be considered really high, which is great. We kind of aim for like 5 and above, but if you have a high tillage system in a really sandy soil, you're more likely going to see an organic matter content of like 2 or 3, which in those systems is kind of where we're trying to keep it. So yeah, sandier soil, lower organic matter. So some of the folks that live on prairie soils or river valley soils tend to have a really high organic matter content. And so the range varies based on your soil type. And what does soil organic matter do? So it does help improve soil structure. Kind of like we said with supply and storing, it's a reservoir of nutrients for plants. It does help with, while improving soil structure, actually increase infiltration of water, which can be huge, and increase the soil's ability to hold on to it. So what we call the water holding capacity, increase nutrient availability. So you kind of see like increased soil fertility, that's some of the same things that improve, soil structure and this kind of thing also help improve soil organic matter and pH. They're all very closely connected. And buffering the pH is kind of that other piece, which is that the pH is able to stay more in the range that we want it to for longer with the same like conditions with the rainfall and fertilizer and management is like the better the soil structure is, the more soil organic matter is, the more it can buffer that pH and keep it at that range. How do you increase it? Kind of some of the same things that we've been talking about. So the crop residues and cover cropping, compost and manure applications. Like I said, the linkages between those different things. Another one that we haven't talked about yet is just biochar, which is kind of a new hot topic that is becoming more and more widely used. It's basically, being that it's like pure humus, it's like the very, very, very dead soil organic matter. And that's the stuff that's like going to create a lot of like resiliency and improve soil health. So we're doing all these things that help us get to that point, but it's going to take a long time. And so biochar in some cases can basically get you closer to that point faster, but it's all part of the same system because you're always going to need things that are actively decomposing for microbes for food at that moment. And then this is kind of like very stable stuff that can help improve nutrient cycling and water holding capacity that do happen over time with these organic additions. So yeah, that's just becoming, it's a really fast way to get some improvement out of the soil. And so it's something that people are experimenting more and more with. So we're going to talk about our macronutrients, which we listed before, but it's nitrogen, And the form that we look at primarily is nitrate, because that's the main form of how nitrogen is available for plant uptake. We look at phosphorus, and the form that's available for uptake is phosphate. Potassium, plant available form that we are looking at is potash. Sulfur, plant available form is sulfate. Calcium and magnesium. So those are our macronutrients, and we're going to talk through why they're important and what the ranges are that we're looking for. So nitrogen. Nitrogen is needed for high yields and high protein content in what we're growing. On the soil test report, here is nitrogen circled. And for this producer, when this was taken, the nitrogen was at 2 parts per million, which is really low. What we expect to see in the springtime, though, because nitrogen, nitrate is not held very well in the soil. It easily leaches out. So the rain, typically with the rainfall and before soil microbes really get going in the spring, once the soil is warm and things are actively growing, we just see nitrogen really low. So that's pretty expected for the time of year that this was taken. And then I kind of wanted to just show how we convert it. So in this report, nitrogen it's in parts per million. Most of these things are in parts per million, ppm. So with that, we needed to convert it to pounds of nitrate nitrogen, so we know what's in the soil and what we have. And this is just an equation that you can refer back to. That tells you, if you take the 2 parts per million times 2, gives you 4 pounds of nitrate nitrogen per acre. And that's what we are doing when we look at this sheet. So for vegetable crops, the range that we're looking for is 25 to 40 parts per million, or 50 to 80 pounds of nitrate nitrogen per acre. So when we know that that's what we need, we can then figure out and determine the rate of fertilizer to apply. And then for forage crops, the rate is a little bit different, 25 to 30 parts per million, or 50 to 60 pounds of nitrate nitrogen per acre. So phosphorus, why is phosphorus important? It's needed for seed germination, crop establishment, and root growth. So in vegetable production, kind of seed germination is the really big one. So why it's important at the beginning of the season, whereas with like forage production, root growth is really important. So having enough in the fall is huge. That's when forage crops are really putting energy into root growth. So here's phosphorus circled on the soil test report, and it is 20 parts per million per acre. And if we remember what we needed, we're gonna go there next. So phosphorus to phosphate, we go with parts per million, times it by 4.6 to get pounds of phosphate per acre. So if we take 20 parts per million times 4.6, that's 92 pounds of phosphate per acre is what the soil test report for this field told us that we have available. And then the optimal range, so it was at 20 parts per million, so pretty close to a degree. We're gonna talk about why it's actually not as close as it looks based on the pH, but 25 to 40 parts per million per acre, and 50 to 80 pounds per acre for forage crops, 20 to 30 pounds per acre, and 90 to 40 pounds per acre. So why is potassium important? Potassium's needed for water transport, metabolic function for optimal growth of what you're growing, and root growth. So also needed for root growth too. Here's potassium on the soil test report. It's at 110. So we have to convert parts per million to pounds of potash. So if we had 110 times 2.4, that's 264 pounds per acre is what the soil test report has. So for the optimal range for vegetable crops, it's 150 parts per million, or 360 parts per million. I'm seeing that the element there is incorrect. It says nitrate, so pardon that error. And then for forage crops, we want 25 to 30 parts per million, or 50 to 60 pounds of potash per acre. So why is sulfur important? Sulfur is needed for proper nitrogen utilization, rapid growth, and protein synthesis. So it really works alongside nitrogen to make nitrogen more available. And here's the soil test report with sulfur. And on the soil test report, it's 6 parts per million. So with that, we convert 6 parts per million times 2 to give us 12 pounds of sulfate per acre. And the optimal range that we want for vegetable crops is 20 parts per million. And that would be 40 pounds of sulfur per acre. Calcium. So calcium is needed for strong cell wall structure, plant growth, and plant development. So thinking about like having really good like plant stocks and like support and above ground growth is like what calcium is really needed for. It's one thing, one of the main things. So calcium in this regard is at 1800, and then what's circled is magnesium. So magnesium we'll talk about next. So the optimal range for calcium that we need is 1,000 parts per million per acre, or 2,000 pounds of calcium per acre. So magnesium is needed for enzyme activation, for chlorophyll production, so which is created in photosynthesis, and also for synthesizing protein, so protein content. And like we said before, magnesium's at 164, calcium's at 1800. So magnesium, we look at 150 parts per million per acre, and 300 pounds of magnesium per acre is what we're going for. And we actually, what's important is a ratio of that. So it's a 7-to-1 ratio of calcium to magnesium. So when we take that, what's on the soil test report is 1800, and we divide it by, what was the magnesium at? 164. We get 10-to-1. So that's, this soil test report is a little bit higher than 7-to-1. But that's kind of the range that we're shooting for in an ideal case scenario. So we're going to look at micronutrients, which are zinc, manganese, iron, copper, and boron. Micronutrients, meaning that we only need small quantities of it. And for forage production, we don't actually really need to look at micronutrients. That's an extra add-on to the soil test, and it's really important for vegetable production and fruit production and some other specialty crops, but it doesn't make a significant difference with growing grasses or established legumes and forbs. So zinc. So for growing vegetables or fruit, zinc is essential for regulating plant growth rate and for the plant to be able to use the chlorophyll that it produces. Here's zinc circled. In this case, it's at 10, which is very high. So the optimal range is actually quite a bit lower than that. 2 to 3 parts per million, or 4 to 6 pounds of zinc per acre. Manganese is our next nutrient we're going to talk about, and it's essential for metabolic function for optimal plant growth and development. So a lot of these micronutrients work with the metabolic processes in the plant and help it be bigger and stronger. Here's manganese circled. In this soil test report, it's at 4 parts per million. So the optimal range is a bit higher, 15 to 30 parts per million manganese per acre, or 30 to 60 pounds of manganese per acre is what we'd like to see it at. Iron. So iron is essential for plant respiration by helping oxygen move throughout the plant. So that's what it's doing. It's similar to what it does in our bodies with being that our blood cells are carrying oxygen and are high in iron. And here on the soil test report, iron's at 52 parts per million, and iron really is rarely low in our region. And being super high, I don't think it makes too much of a difference. Some people think that if iron's high, you might need to add more of certain micronutrients, but it's just kind of something that we manage for in this area, and it's just typically high. It's what we've got going on. And so, but typically you don't need to add additional iron to your soil. Then copper. Copper is essential for photosynthesis, plant respiration, and plant cell wall development. And on this soil test report, copper is at 1.4 parts per million. With vegetable crops, we're looking at 1 to 2.5. So it's really in the optimal range. Really, it's pretty good in this soil right now, which 1.1 to 2.5 parts per million equals 2 to 5 pounds of copper per acre. And then boron. So boron is essential for high yields. It helps move plant sugars, which is their energy source, into the growing parts of the plant. It helps with pollination and seed set. So those are some of the things it does in fruit and veggie crops, and so it can be really important for fruit production. And it does do one thing for forage crops, and that's if you're establishing a new field or a field that you're doing a full renovation on that you're tilling, and you want to add more clover. Boron is actually essential for what's called nodulation in legume and forb crops, and that nodulation is actually this really interesting symbiotic relationship with bacteria. But ultimately what it does is help the plant actually take nitrogen from the air and convert it into a form that the plant can uptake. Pretty freaking cool. It produces its own nitrogen. But yeah, so if you're establishing a new field, that is when you would need it. Otherwise, not important. That nodulation in those established fully mature plants is already happening. Here's boron on the soil test report. It's at 0.2 parts per million. The optimal range in vegetable crops is going to be 1 to 2 parts per million, or 2 to 4 pounds of boron per acre. So in the soil test report, we're a bit low, and that's pretty common that boron is something in very tiny amounts do you have to supplement every year. It like nitrate nitrogen isn't held well in the soil and leaches further down past the root zone or runs off. So it's just something that we tend to be low in, and not all vegetable crops need boron in this range, but certain crops really do better without it, and certain crops will show plant stress without the right levels of boron. So when we're talking about what is going to make the most difference, so there's lots of different things that we said were high and low in that soil test report, and it's when it comes to fertilizing, it's kind of important to just consider what to prioritize. And fertilizer is really expensive. It might not always make the most sense to apply every single thing that we see that is needed when we look at a soil report. Instead, we usually start in one place and see what the crop's response is to that. So especially in perennial systems that are a little less sensitive. So when it comes to forage crops, pasture and hay, when I'm working with folks and we're trying to improve fields and improve fertility, we really start with the main thing, which is improving the pH. That's always going to be the first thing that you want to improve. And in some cases, this just might be you growing things for you and your family, or maybe you got pasture and you're producing a hay crop, but you're not you're not trying to get the best possible yield. We're always going to start with limestone applications to improve the pH. The next thing that we would focus on would be manure or compost applications. And so the reason for that is that might be something that's easily available and readily available and has multiple benefits, right? It's got that alive, dying, dead, very dead organic matter that's going to have a whole bunch of benefits that we talked about, including a slow breakdown of certain nutrients. So manure, being that it's pretty available, is the next thing that we would try to prioritize and focus on. And then we would look at the most limiting nutrients. So what nutrients are the lowest, the most, that's going to be very mobile in the soil, so aren't going to, we're going to see it pretty low every spring. That will significantly increase yield when applied at the recommend rates. So typically with the most limiting nutrients, we usually start with nitrogen, and nitrogen and sulfur together is what we're going to talk about right after this, which is it improves the crop response. So, but most limiting nutrients, you probably hear a lot about nitrogen. So that's kind of why that one's such a big thing. And then the most mobile nutrients, so things that are, maybe for your vegetable crops, for certain ones, boron is going to be something that you really need to focus on when it comes to micronutrients. And then at the bottom, it's rapidly decreasing nutrients. So this is helpful for just thinking about your prioritization. And rapidly decreasing might be potassium, for example, whereas phosphorus would probably be more of a most limiting nutrient, because especially in vegetable production, because it's going to impact your plant's ability to, seed germination and plant establishment is going to be huge there. So that's kind of what we start to think about when we think about what's the most important thing to apply, if I were to apply one or two things. And then nitrogen being such a big thing and being something we are usually applying, there are different ways that we can make sure that what we apply nitrogen wise is absorbed, has the best ability for the plant to uptake it. So we have the highest nitrogen fertilizer response when the pH is in optimal range, when nitrogen is applied with sulfur. So for conventional nitrogen sources, that's usually something like ammonium sulfate, or in organic systems, we get sulfate from something like potassium sulfate, and then we add a nitrogen fertilizer source on top of that. when phosphorus and potassium are at the optimal levels, you are going to have a better nitrogen fertilizer response. But, you know, like we just kind of talked about, the goal is to get there, but maybe that's not the first thing we need to focus on. And then applying the right rate at the right time based on your soil test results, because some things actually don't need more nitrogen. Like not adding more nitrogen is not always going to be helpful. Like adding more than the recommended rate is what I mean by that. So that's a big piece of it too. And the rates that we recommend when we are calculating how much fertilizer you need, we're looking at what's been done at with university extension research. And so what they've done is they've done something like apply a bunch of fertilizer, and they've monitored the crop response rate, and they've, you know, if I apply 20 pounds of this or 30 pounds of this, and they've figured out what the point is for when yield and like plant health taper out, like when it's not actually increasing anymore. So that's part of like how we've come up with the rates that we utilize. And we look at university extension research and their publications for determining these rates. So we're going to talk a bit about how to calculate the fertilizer rate, which is kind of maybe the most obscure part, and for some people the part they're most interested in learning how to do themselves. And we need a few things. So we need to know the pH, which if you've taken a soil test you'll have that, because we're going to look at the nutrient availability based on pH. We need to look at the optimal nutrient level needed. So what does the crop need? How much nitrogen does it need, for example? And then we are gonna pick what the current level is, sorry. And then we're gonna pick which fertilizer we want to use, whichever one we pick. And then the fertilizer itself should tell you on the box, or, you know, at the store, if it's in, you know, whatever the package is, should has the percent of each nutrient in the fertilizer. So the NPK-S, so nitrogen, phosphorus, potassium, and sulfur. Those are the elemental symbols, which, right, we need. It's going to show you the percent. I guess that's kind of important, is it's going to show you the percent nitrogen, not the percent nitrate, necessarily, especially for organics. So we're going to talk about that in a second. Yeah, and this just is a good segue into this piece. Now, I've mentioned a few times that nutrient availability changes based on pH. So I'm going to explain that really briefly before we try to calculate anything. So in order to keep nutrients in the soil as available as possible and in the range for most crops on average, since we're aiming for that 6 to 7 pH range, we, you know, like I said, if we are lower than this, if we are down in this area with the nutrients being less available, there's actually sort of rates that we look at with that, like what percent is available. And so that can kind of help us determine when we're calculating what we need to pay attention to. So in this case, we've got a pH of 6. And then what percentage of nutrients is available for plant uptake? So if we've got a pH of 6, then we know that about 90% of nitrate nitrogen is available. So at a pH of 6 with 90% available, that's important. Just remember that for the next part that we're going to do when we calculate it. And I guess I'll just briefly say this chart, which this presentation will be made available to you afterwards. This chart shows you the percents for different nutrients. So you can see that at a pH of 6, only 52% of phosphate is available, which when I said phosphate, phosphorus is a pretty limiting nutrient. That's kind of why, is it's the closer you are to 7, the more available phosphorus is, and that's pretty big. So 6 isn't too bad. When we look at nitrogen, then we know that vegetable crops need, for nitrogen, 25 to 40 parts per million, right? We talked about this, 50 to 80 pounds nitrogen per acre. And then if the pH is 6 and 90% of that is available, which, let's go with the higher number. So if we looked at 80 pounds, for example, 72 pounds is what's 90%. So we need to apply 110% of the crop need to account for that availability. So that's where knowing the pH is really important. If you're really focused on making sure that something like nitrogen is in the correct range for crop growth. And this becomes more important the more acidic or alkaline your soil is, right? Like if I have a pH of 5 or 5.5, that's going to make a huge difference with nitrogen, and applying the right amount is going to really impact yield and plant production. So if we need 50 pounds at the lower range of that, to get up to 110%, I just multiplied it by 1.1 is 55 pounds. So in this case, it's not a ton more, but that just is, a reference point and an example for how much you would need. So yeah, 50 pounds becomes 55. So if we need 55 pounds of nitrogen per acre, let's say we're doing vegetable production here and it's organic, we'll use feather meal. How much do we need to apply? That's the thing we're trying to answer. So feather meal is, if you looked at the package, it would say 1200. So what that means is it's telling you that there's 12% nitrogen, and that's only actually 6% nitrate. So organic sources of nitrogen, like feather meal and chicken manure, you can estimate about 50% availability unless the fertilizer company or company that you're working with says something different. We estimate that it's about 50% right away is available for plants. And then the 1200 is 12% nitrogen, 0% phosphorus, 0% potassium. So one reason that why we use feather meal so much in organic production is 12 is actually a pretty high percent, whereas like chicken manure is 3%. So you just have to apply a lot more. But chicken manure can be cheaper. So there, you're always weighing those different options, and there's definitely a whole gamut of fertilizers to choose, for sure. So with feather meal being 1200, we want to know how much we need to get that 55 pounds. So 950 pounds times 6, so 6% of that times 0.06, 6% of 950 pounds is 57. So that, I rounded up 950 to get us, because you're going to use 50-pound bags, and that's per acre. So that sounds really high, but that's per acre. So then when we look at the rate recommendation here, it's 950 pounds per acre, but now you get a sense of organic veg production and how much fertilizer they need. Or if you have a small area, that's 22 pounds per 1,000 square feet, or an even smaller garden, that's 2.25 pounds per 100 square feet. So this is a rate to use based on the soil test report. And remember that the rate varies based on your pH. So for someone who has a pH of 6, this would work. And since we start at almost 0 in the spring, we're almost always going to add the same nitrogen amount here. We're going to need the whole 50 to 80 pounds per acre recommendation. unless it's a greenhouse. If it's a greenhouse where there isn't rainfall and a ton of irrigation happening year round, right? There hasn't been a ton over the winter, then typically there's still nitrate left in the soil. And so it's really important to take a soil test to manage for that. Okay, so we looked at organic veg production. For reference, I'm going to do a forage crop example. So forage crops need 25 to 30 parts per million, or 50 to 60 pounds of nitrate nitrogen per acre. So again, with the pH of 6, that's 90% that's available. Again, we're going to apply the 110%. So 55 pounds in this case is what we'll apply as well, staying at the lower end. So if we need 55 pounds, we're going to use just a conventional nitrogen fertilizer, ammonium sulfate. So if we need 55 pounds, how much ammonium sulfate do we need to apply? Ammonium sulfate is 210018. So it means we've got 20% nitrogen. And with a conventional nitrogen fertilizer, everything is readily available all at once. So we know there's 21% of nitrate nitrogen. Again, so yeah, ammonium sulfate, 100% available right away. 0% phosphorus, 0% potassium, and then 18% sulfur, being ammonium is the nitrogen part and the sulfate being the sulfur part. So 210018. And now we know with that, right, we're trying to figure out how much we need to apply. So in this case, we know that the math here that I did, if we apply 300 pounds per acre, 21% of that is 63 pounds. So we're getting closer to that 55. I rounded up, so it'd be easy. Everything, that's why we give ourselves a range, because it's approximate. So that'd be 300 pounds ammonium sulfate per acre. If you have a smaller area, 7 pounds per 1,000 square feet. So there's some information there. Again, putting that reminder down that the rate will vary based on the pH level. So those are a couple examples. They're kind of complicated, but my goal there was to show you what rates we would do, or like how we would calculate that. So this is a reminder of the things you need in order to do those calculations, like we talked about at the beginning. And this is where I cue in the fact that we do soil testing with our farm assistance program, and we'll come out and we'll take soil samples. If you qualify, so if you're a commercial crop producer or if you have a pasture hayfield, we will take soil samples and then we will do the interpretation and provide the recommendations, so that all that math, you don't have to do it. We'll do it for you. And there are some options if you just have small garden, or you don't have a commercial crop, or you don't have a pasture or a hayfield. There's a couple different districts around here that do have a soil testing program that will do things for garden crops and such. I'll provide a resource for that at the end, but Thurston Conservation District, our neighboring one, has a soil testing program, and they will take samples from gardens and interpret those as well, and lawns. So we also have an equipment rental program. We do things like we have manure spreaders. We just got a lime spreader. So those are, the manure spreaders and the lime spreader are both ground driven, so you don't need a PTO. And each one requires different amount of horsepower. So that's all information that can be available to you. I'll provide a link for all of that as well. We also have a couple different pieces of equipment. Those are the huge ones, but we have a hay probe for testing hay, if that's something that you're wanting and needing to do. We also rent out a no-till seed drill. We have a 4-foot now, which is our new one. It's smaller. It can handle a smaller tractor, which is really exciting because for quite a while, we've had just our 6-foot no-till drill seeder, which we still have, but it just requires a higher horsepower than a small tractor does. It's been a limiting factor for folks to use it. So we're pretty excited about having 2 options now. If you're reseeding an pasture hayfield or you're seeding cover crops, we have a cover crop cost share program that actually might be something you're interested in if that applies to you. So some different resources there. And then we also have a flail mower if you're growing a cover crop that you want to seed directly into. So a few different things. And then we offer technical assistance. So we will come out and do a site visit and talk to you, hear about your goals and concerns and how we can help. We'll do soil testing and we'll also do farm planning. So that's an option for you. And we do have quite a few recorded webinars on our website, which is pretty awesome. And maybe just one thing that has come out of COVID is that we have all these virtual workshops now, and we are recording them. So now we have this library, which is a pretty incredible resource to provide for folks. And we have how-to videos as well. So I already went through this list, but I'll put it here. And I think just a couple of things that I didn't mention yet. Electric fencing. If you are new to and curious about rotational grazing, we can loan out electric fencing material. So it's something you can reach out and ask questions about if you're interested. We also have poultry processing equipment. We have 2 different units. If you're growing and raising your own chickens or turkeys. And then we also loan out livestock water pumps, which if you're providing water for your livestock coming directly out of a stream or a creek, this is an alternative to that. So if you're interested in any of these things, please feel free to reach out to me, send me an email, give me a call. And then I just wanted to list a couple of upcoming events. We have a livestock-based workshop talking about mud management coming up later this month. This is this first one, but it's part of Harvest Pierce County, our program at the district, their edible garden series, and it's garden planting and seed starting. So there's actually quite a few more webinars and free workshops that they're going to host around gardening if you're interested. And then we've got a workshop on wildfire risk, managing wildfire risk around your home. This is part of a forestry series of workshops that will be recorded as well and made available. And we also have an upcoming work party for planting and maintaining our South Prairie Creek Preserve site. And this is just a plug-in for the fact that we do have a lot of volunteer opportunities if you're interested in being involved in that. And that is the end. Thanks for sticking with me through that. And my contact information is here. If you have questions or you're curious about getting a site visit or a soil test, or talking about anything I didn't cover or something you want to know more about, please feel free to reach out. And thank you so much.